потребности общества, да, то есть просто профессиям, трудовым навыкам я доверяю, да, понимаешь? Если ты идешь в музыку, блин, там Скрябины, виртуозы, что-то там ненормальное, нечистое, что-то там, например, или наоборот. А я доверяю, я знаю, что это, ну, они не дошли, а я дойду. Они будут, да, что есть продолжение пути, и оно все равно будет неважно, идешь ты, да. Ну, это не надо, что всегда, да. Так же, как и, да, ну, наверное, понял ты меня, короче. Нового века, и не только нового, а по сути, по смыслу, да. Для чего, да, вот, понимаешь, эволюционно, да. То есть я тебе точно говорю, что дела это святое что-то, это что-то, да. И это единственное настоящее. Все остальное это ложь, да. Все остальное жизнь не нужно. Все остальное это просто извращение, миллионы чакр, вот так вот. Ну, выходишь на завиток, и все, зачем тебе лишнего? И все, как бы, это, провило, ну, как бы, ладно, это же, провило. До свидания. Ну, вертикально, да, да, новое пространство, да, да. Я говорю, все, да. Короче, жить можно. Жить это хорошо. Но очень сложно. Да. Объем работы, не злокозненность, а объем работы. Да. Ну, да. Мелкота, крупное дело какое-то. Да. Ладно. Да. Собой. Может, если ты музыкант, да, да. Да. И это весело, это интересно. Да. Да, даже так, вот просто я к чему говорю-то? Потому что никаких, вот только так или смерть, есть жизнь. Сделай это, есть жизнь. Но она как бы очень дозирована. Ну да, да. Все остальное это как бы время заблуждения, как угодно. Оно тебе нафиг не надо. Чем объем работы. X, да. Ну, ценой можно. Ну, или вообще в целом. Да, наверное. Да. Объем работы просто. Да, да, да. Да. Делаем надо. Да. Так. Очевидно.
Don't make this mistake. And no, it's not that I haven't seen the sun since the quarantine. Or even I'm wearing mismatching socks on this yoga mat right now. It's doing sit-ups or keys that can hurt your low back. Well, as a doctor, you have 4 board certifications. It's sleep medicine. So you spend a lot of time researching how light impacts us as human beings. And I know you're very excited
The average American spends 93%, that's 87% of our life, is inside buildings, and another 6% on average inside automobiles. So tell us why you're so excited about this topic, and are we going to get some practical tips that we can implement right away? Yeah, thanks, Kyle. I became excited about this because as I started to learn about what scientists are discovering, it was mind-blowing. I mean, ultraviolet radiation from the sun and its role in our bodies. But there's a whole other aspect to the light that we get from and light that comes outside. It affects us, the infrared spectrum and how it affects us. Beyond the science of this, which we'll talk about, we're going to practical tips to harness that information and actually apply it to your body. And as you'll see, the results of that can also help in things like actions. But the nation in this video, I believe, is so important that everybody needs to be able to understand this. And that's the reason I'm so excited. So to explain why light is so important to the human body, not on a level, and explain this sort of at the outset. To do that, I'm going to explain what I'm talking about. So in every cell of our bodies, we called mitochondria. Mitochondria are like a car. It produces the power, the energy, and for the body, it produces ATP, which is the currency of energy for our body. But just like a car, it can shut down, and that's a byproduct of what it does. It's a very similar situation in the mitochondria. The mitochondria takes the food that you eat, the fat, proteins, the carbohydrates, and it makes it that your body needs. But a byproduct of that is oxidative stress. That's the heat. Oxidative stress builds up too much. So what are some problems you can run into if you have too much oxidative stress? What scientists have discovered and looked at is that there are a lot of consequences to oxidative stress. Less optimal health, dementia, diabetes, and learning disabilities have been tied to oxidative stress in the mitochondria and mitochondrial disability. Okay, so mitochondria are in all of our cells, and you see that they're like a car. They can over and have problems. What would be the cooling system, if you will, in our mitochondria? Actually, the body has two different systems to be put in place that takes care of the mitochondria, cooling it down and getting rid of the oxidative stress in the mitochondria or night. Fascinating. Many of us know about what the cooling system is at night because we've heard of it before. And one of the things that is done is that melatonin, which is one of the antioxidants that has been studied, it actually regulates the glutathione system. Twice as powerful as vitamin E. Melatonin is secreted at night from the pineal gland, goes into the blood circulation, goes into the cells, and is actively transported in, and then goes duty to mop up these oxidative stress molecules. Okay, let me explain this. So in the melatonin is released in the pineal gland, and we heard that melatonin can sleep. People take melatonin as a sleep supplement. I know it's important for that, but you're saying it also goes into the mitochondria of our cells and combat oxidative stress? That's exactly correct. Okay, the process works at night. How do mitochondrial cells deal with oxidative stress during the day? Well, that's a very good question, because any type of light that hits the human eye is going to shut down the production of melatonin from the pineal gland. And so there has to be a completely different system that is put in place during the day that allows melatonin to be made in the mitochondria to deal with the oxygen. Remember, we said that these radicals, these oxygen radicals that are produced in the mitochondria as a result of metabolism can destroy things immediately in its vicinity. So you need to have antioxidants right there on site And the question is exactly how does this happen during the day? And the answer is that infrared from the sun, which we'll talk about, actually goes into the mitochondria and is producing melatonin on site. This is what the science is now starting to discover, making it very interesting as to how much sunlight are we getting and what happens when we get enough sunlight.
So is oxidative stress always bad for us?
No, oxidative stress can actually be beneficial if it's in the right place. So oxidative mitochondria is just going to serve to break down the proteins of the electron transport chains, which we'll talk about in this lecture. But it's very important for cells, for instance, like white blood cells, which are responsible for killing bacteria, to have within them the ability to have oxidative bursts and oxidative stress. So in certain places, oxidative stress can be very beneficial. But in the mitochondria, no. The body needs systems in place to protect the mitochondria because it's doing a very important work.
Many of us have heard that not all light from the sun is visible light. So can you break down the solar spectrum for us?
На Сбер со скидкой до 10% за бонусы от Сбер. Спасибо. Сбер Мега Маркет.
Наоборот, да нет, понимаете, наоборот, это вот она имела в виду, да. Да, наоборот, это, ну, вот это было самое. Да, наоборот, да, наоборот, да. Наоборот, наоборот, ага. Наоборот. Нет, наоборот. Что же вы плохого видите? Хорошо, а что, да.
Yeah, Kyle, let's take a look
Я
at this.
тоже вот так вот, да, понимаете. Ну, да, это эти советскую девочку делают, постсоветскую. Что ли. Видишь, какая ситуация? Да, да, то есть, да, понимает она тебя. Да, чтобы красота развивалась, правильно? Для души, нет? Красота развивалась, и чтобы она могла творить детей красивых, добрых, наверное, не знаю, да, наверное, да. Чтоб солнышко было, нет, нет, не знаю, что делать, да, да. Наверное, да.
Solar spectrum, which looks at the from the sun. Sometimes I don't like to use the word light, but I will use it because
если вот
it's
капризная будешь, не факт, что это будет легкого, или еще чего-нибудь. Да, даже если ты будешь, потихоньку света. То есть, да. Или, да, понимаю. То есть это не да. Да. Жить тяжело будет, понимаешь? Жить тяжело, да. Ну ты ешь мысли, да, наоборот, это да. Это с этим делом,
feels that something that we can see, but clearly there is energy coming from the sun, which we
это не
cannot see.
вульгарно,
That's
ну, понимаешь?
important.
Да, а значит, сами себе, наверное, нет, наверное, да, просто, да. Все остальное несущественно, и подделка настоящего человека. Знаешь, подделка человека хуже, не знаешь, хуже. Ну, так, не знаю, да. Да. Тем более искусство. Искусство, оно изначально просто artificial, просто все. Да. Но это не значит, что это ничего. Оно не нужно людям, за него деньги не платят. И людям, то есть, ну, в каком-то смысле искусство реальнее всех реальностей, да. Но это в мужском только смысле, профессиональном, да. Да. Ну, наверное. Ну, это она имеет в виду, если о тебе так говорит. Ну, это будет. Ну, наоборот, значит. Ну и что, и что это нет? Ну, тогда, значит, оно никому не нужно. Никто и весь не понимает. Вот это, на себе берет, тогда, об этом не будет. Что это все, да, что недоумки занимаются искусством, а надо заниматься чем. Да, то есть, ну, хорошо, да, да, да. Хорошо, при делах выше, да, да, это знание, да, это говорил, да, да. Ну, да, да. Да, да, да. Брание это время, это, конечно, не, да, да, часто разговаривать, ну, хорошо, для недоумка, потом, когда застрял, помнил, не надо показать. Как она обследовала. Ну, кому уже все. Да, да, да. Ну, это массовое искусство, да? Смысл, хорошо, философия искусства. Это уже определенно, это уже философия, что искусство только для масс. Правильно? Да, то есть это уже позиция. Есть еще и другие позиции. Ну, но для этого надо, ну, да, для этого надо хотя бы образование, для этого надо, да, и еще деньги за это. Ну, чтобы пощупать хотя бы, что общество. Да, потому что есть биеннале, например, да, и прочее. Да. И тоже биеннале. Да, ну, ладно.
The solar spectrum, we'll see that 39%, just 39% coming from the sun is in the form of visible light. And we can see that here, between 400 nanometers and 760 nanometers wavelength. We'll talk about wavelength. And so you can see everything to the rough red is known as infrared because it has a wavelength longer. And that is divided up into near infrared and far infrared. We'll talk about this more. Don't get too concerned about this. But specifically, we're going to talk more about infrared and its benefits. And that's between 760 nanometers. We'll come back to that. At the other end, all of the light, as you can see, that is beyond the purple or violet in this case, all ultraviolet is not seen, but we know that it's important, specifically UVB, important in making vitamin D. I want you to notice something very important. 54% of all the energy coming from the sun is in the infrared. Remember that, we're going to come back.
The sun is putting out a lot of energy, and of that energy, a spectrum of light. Are there other aspects of visible light that I just found?
Yeah, so in order for us to give recommendations and for us to be able to measure the effect, one of the things that's really important is understanding what lux is. And so we've got an example here where we have a candle, which is 1 lumen, 1 meter away from a board, which is here by 1 meter, and that's described as 1 lux. I'm saying this because we're going to be using lux a lot, so you have to understand that 1 lux is pretty dim light. In fact, let's talk a little bit about some different examples so you can understand what lux is. And in this slide here, you have one that's kind of like twilight at night, and that a family living room is about 50 lux. But it can go all the way up to 1,000 if you had an overcast day outside, and if it was a bright, that would be around 100,000 or even more lux. So that kind of gives you an idea when we talk about exposing your eyes to light at a certain lux level. This is a good reference point for understanding light and its intensity. With that information now,
Ну, то есть свет, отношение с светом, да, тоже здесь понятно. Так хороший, да, да. Ну, от тебя зависит. Просто это тоже сам понимаешь. Вот. Ну, да.
Need to talk about light and how it affects the human body. This is going to be divided into 2 parts. The first part is going to be what happens at night, how we divide the night from the day, and how sleep and the circadian rhythm is affected by light. The second part is going to be on how light affects us directly with infrared radiation and the mitochondria. And I think that's going to be the part that for most of you probably never heard before. So stick with us as we go through this. There's going to be a lot of interesting, informative aspects of it. Let's talk about how sleep and the circadian rhythm is affected by light. So if you've ever been to a conductor, is the one that's conducting the orchestra, and each one of those players in the orchestra is starting and playing their instrument. They all have to start at this, otherwise the music is not going to sound right. So there are processes going on. There is a violin in one portion of the body, to use that analogy. But to make sure that everything, there has to be a conductor, a master clock, and that is known as the circadian. So I want to show you this slide, the circadian rhythm. Now it looks daunting, and that's actually part of it, to show you how things in the body have to be coordinated. I want you to think of, let's say, Disneyland. In the morning, and you can go through rides and attractions are running. You know that as soon as Disneyland closes down at night, and I had a friend that used to work at Disneyland, there's so many things and after hours to make sure that the park is ready to go the next day. The trash has to be taken out, things have to be cleaned out. It's a new day that's about to happen. And the same thing happens in the human body. The human body is extremely complex. Because of that, there are so many processes that it's not just one continuous thing. There are times of the day where certain things tend to happen and times when other things don't. So I want to show you here what I'm referring to, and just to give you an example of what we talked about with oxidative stress, we can see here that melatonin secretion starts at 2100. That's about 9 o'clock at night. We call that dim light melatonin onset, because if you are watching dim lights, then it's going to basically start to secrete melatonin from the pineal gland. But if you notice, as we go around this cycle, melatonin will stop approximately 7:30 in the morning. It's interesting because around that time, cortisol levels start to peak. And they go around and finally die out at around the time that melatonin is starting to come on. We'll talk more about that cycle, but if you just look here, you don't need to know that. You can just see, for instance, that your fastest reaction time is around 15:30. That's about 3:30 in the afternoon. We know that your highest alert is around 10 o'clock in the morning. Nation is around 2:30 in the afternoon. All of these things are happening because there is a master clock that's coordinating all of the smaller clocks to be on at the same time.
Okay, Dr. Schwell, a couple questions. Number one, you said melatonin secretion starts at about 9 p.m. But I imagine it's variable from person to person, and also, of course, depends on whether or not they're viewing bright light at night. And the second question is, you mentioned the dim light melatonin onset. Is it actually the viewing of dim light that stimulates melatonin release, or is it just the absence of viewing bright lights that actually stimulates melatonin release?
Yes, both good questions. Dim light melatonin onset is kind of a bad name for it because really it's the absence of light that allows the pineal gland to stimulate and produce and secrete melatonin throughout the blood and the human body. You're right that it may not be 9 o'clock in everybody, and that's the problem. Is this circadian rhythm has to fit onto reality. This is a clock that's going on inside your body. But the problem can come in is if your clock is not in tune with what reality is on the outside. In other words, there's a certain way of your body, your circadian rhythm, that's attuned to when you should awake. And if it's not correlating with when the sun is up, you might have some problems. So yes, the circadian rhythm, which is very finely regulated inside the body, but the question is it actually in line with what's happening outside the body, what reality is? And that's the question.
You mentioned that it's key that our internal clock, our circadian rhythm, is optimally aligned with reality, and that there's all kinds of potential benefits and consequences to that. What are some of the specific things that our circadian rhythm regulates?
Well, if you look at this list, this is pretty extensive, Kyle. I mean, circulating melatonin, we know as an antioxidant. There's studies that suggest that it can reduce cancer. It reduces cortisol production, which is what you don't want to have at night, which is good. It's an antioxidant, and it promotes sleep. That's just the melatonin aspect. But the circadian rhythm also is used in regulation with peripheral clocks, eating, and the fasting rhythms, right? So you're not typically eating at night, you're eating during the day, and so those are coordinated. We have hormones that go throughout the body like cholecystokinin, leptin, and ghrelin. These are involved with diet. These are involved with being hungry and with being sad, body temperature, glucose metabolism, the pancreas, and you can see some of the other ones there. Vasopressin, which is a blood pressure hormone that determines when your blood pressure should be high and when it should be low. Obviously, lower at night, resting. Acetylcholine is very
да, ну вот ты просто я так же так сказал, да? Да, то есть это есть оно самое. То есть рот происходит, если ты отрекаешься от него, да, то есть слабок просто вот и все, слабина, понимаешь? Слабок, да, вот. Очень надо, понимаешь, даже в принципе, он тебя понял уже, да. Работать надо, просто пасовать, да. Ну ладно, пацану, а дальше что? Завтра есть. Завтра можешь набрать сил уже и, да, профессиональных, так сказать, да. Ну это имею в виду, нет, я не имею в виду бабки нагрести. Ну, да, я имею в виду, ну, про себя так думаю, да. Смотри, потому что бабки, это то, что вот тебе дали бабки, представь себе, что ты животное, и, ну, какой-то вот, ну, ты в лотерею выиграл, что тебе с деньгами будет, ну, что тебе вот бабки дали, но ты их не заслужил, что произойдет? Ничего не произойдет, все, у тебя не будет их скоро, понимаешь? Вот и все, да, понимаешь? Вот он имеет в виду, да. Или что ты животное, вот тебе что-то дали, представь себе, собаке дать коттедж, что она с ним будет делать? Понимаешь, то есть, она поняла ты. То есть, да, то есть это, ну, бред нечеловеческий, потому что собаке не нужно это. Да. Собака это, ну, я просто так шучу уже. Собаке дать 1 000 000 рублей, что она с ней будет делать? Да, понимаете? Ну, да, понятно. Не, надо опираться только на то, что ты заслужил, на то, что ты себе, на свои навыки, что ты, да, которые, вот они, это и есть больший актив, чем просто деньги, которые тебе дали, понимаешь? Деньги это пассив, умение зарабатывать это актив, умение зарабатывать, положившись на себя, как, ну, кроме того, а как тебе надо, значит, прийти к людям, что-то там сказать, здравствуйте, там, пианино поставить, что-нибудь начать играть, как бы, да, ну, хоть куда, понимаешь, к примеру, это просто говорю. То есть это тоже Ну, и это тоже навыки определенные, да, и ты, ну да, и так далее, короче, долгий разговор. Да. То есть, ну да, для этого надо. И главный-то момент, тебе за что деньги? Да за пианино и буду, а ты в каком она у тебя форме? Вот и все. Если ты, да, вот и все. То есть, вот и, ну, умеем, да. Ну, типа того. Вот я про это говорю. Да. Думайте сами. То есть, каких сил и как будешь набираться? Нет, деньги, но экономить денег и уехать куда-то, это бабский вариант, сразу же не мужской. Понимаете, да? Научиться зарабатывать и быть на крыле, и научиться тратить даже деньги, расходовать их осознанно, да, это уже какой-то навык, это уже ближе, ну это уже, как бы, да, понимаешь, это уже, значит, меньше рабства, меньше зла, и это значит, что ты лучше выживаешь как мужик, понимаешь, а просто жить с деньгами просто это, ну, понимаешь, ты знаешь, что вы имеете в виду, вот это вот, деньги, за которые ты отвечаешь, вот ты слово не то сказал, и тебя с работы уволили, например. И да, типа того, да. И что ты хочешь сказать, то что ты не специалист, на другую работу тебя не возьмут. А работать сам по себе, то есть, а ты, да, ты себя не развивал как специалист. Вот это имеет в виду, да. Нет, в смысле покладистый, что двигаться по это самое, он про себя говорит. То есть, что вы имеете в виду? Специалист – это самовыращенный. В любой стране мира ты будешь на пианине играть, понимаешь? Это как бы неважно, но он про себя так говорит просто, да. Специалист, да, и денег заработаешь, если хорошо играешь, это я тебе точно могу сказать, да. Просто в коридоре где-нибудь. В каком коридоре сумасшедший специалистный урод? Да. Ну, он про себя так говорит, да, в коридоре власти. Это не коридор власти, это твоего безделия коридор, твоей беспомощности, да. Сам, да. Ну, я понял, мне это не касается, да. Надо держаться только за свои навыки, за себя как за специалиста. Не где-то припаяно к чему-то, да, не раба какого-то учреждения или страны даже какой-то. А, ну, раба своего дела, это тоже, смотри, взяли тебя там, да, смотри, а что ты имеешь в виду? Да, ну и что, ну тогда, ну, про себя просто так думает. Да. Ну, то есть навыки, надо что-то уметь. Ну да. Умение зарабатывать денег как музыкант, да, ну, типа этого, да. Это не беда, даже если ты приехал, у тебя такого умения нет, но это не лучший вариант, потому что лучше сразу же, потому что иначе тебе, смотри, вот ты тратил время как музыкант, ну, какие-то музыкальные деятельности, полуоплачиваемую, да, или около музыкальной, ну, там, неважно, как скажешь, все словеса. Обучение музыке, например, да, плюс импровизация, экспериментация, да, потом ты раз приехал, и тебе пришлось там какой-то, ну, недостаточный квалификант для чего-то, и ты работаешь 8 часов в Макдональдсе где-нибудь, вообще в Яндексе, вообще без разницы. Какой Яндекс, я просто, где ты там найдешь Яндекс, я просто, ну, когда каким пешеходом там, да насрать мне на это, наплевать, на неквалифицированной работе, имбецильной какой-нибудь работаешь 8 часов. Ну, 9-10 часов, какая нахер разница? Остальное время тратишь на то, чтобы совершенствоваться как музыкант и, да, и выступать, да. Тратишь на себя, на свою жизнь, да. Понимаете? Я не думаю, что вы все уроды. Недоумки все, блин, тупорылые. Что вам ваша жизнь, да. Я еще раз говорю, единственная жизнь. У тебя мечта есть, ты мужик, нет, у тебя есть мечта. Ну, так, ой, чтобы жить нормально, ну, тогда тебе на Запад надо. Так получается, если у тебя такая мечта постоянно, понимаю. Ну, да. А ты что, ничего, уметь ты не хочешь ничего, что ли, делать? Да, ты не хочешь быть мастером в чем-то. Не хочешь всех победить или что-нибудь там, не знаю, да, самым умным. Ну, я всех победить имею в виду, как бы, на арене бизнеса. Какой политическая арена я не рассматриваю, это для слабаков все. Победить всех на политической арене, это значит, как бы, ничего хорошего это не значит. Это Наполеон, который вечная война, вечный психиатр. Меня это не касается. Я просто, ну, или Махатма Ганди тоже думаю, психиатр. Это шутка уже разговора. Это не суть разговора. То есть политика это всегда как бы... Я про политику, потому что, ну, да. Я имею в виду дела. А политика, она туда не входит. То есть, да, ну да, дела это мужество и слабость, которая становится нужной людям, становится силой, да. Ну, настоящей силой. то есть человеческой. То есть, если бы и тогда бы эволюция вот таких вот самые высшие существа на планете, ну вот как вот этих японских мультфильмах были такие. Да, понимаешь, то есть эволюции не надо это все. Самые высшие существа на планете, у которых больше масса мозга, то есть мускулатура, вертикальное хождение и слабая мускулатура, но которая достаточно, чтобы держать тело вертикально и для того, чтобы мозги хорошо варили, может, даже так, наверное. То есть, если уж так совсем, ну, неважно. Да. Ну, да. Вот, ну, да. Здесь можно, ну, то есть, да. То есть, приезжай туда, ну, и что, будешь развиваться, будешь холопом там бегать. Какая разница, здесь бегаешь, там бегаешь, да. Ну, это тоже может быть. Ну, ты учти это, да, понимаю. Ну, да. Что-нибудь тебе надоест, скажешь, нет, надо обратно. Да. Ты, наверное, нет, ну, вот это и есть, да. Место, где можно трудиться. Ну, они там тоже как тяжело живут. Ну, не знаю. Вот это он не пройдет. Думай сам, где все строить. Всякое. Да. Там, где плюс, там все ценится. Ну там это меня не касается. Ты можешь сам себя выпустить. Может, у них просто он тебе представляет. Но это не суть. Ты для кого-то будешь жить? То есть, да, ну не важно. Ну, амбиции свои. Может, хочу быть клевым музыкантом. Например, да. Ну ничего, все равно у тебя времени полно. Что ты будешь с ним делать-то? Ничего, дашь деньги, а потом что будешь делать? А пока параллельно даешь, все равно у тебя сколько-то есть, и выходные какие-то. Семье ничего не надо. Да, семья без тебя обойдется. Да. Семье надо, чтобы ты был кабинет, чтобы у тебя был. Чтобы ты мудрый был. Нет, чтобы ты мужчиной был. Не надо на семью ничего сваливать. Из-за семьи у тебя нет, не надо на других людей пытаться приложить, что ты недоумок, понимаешь? Потому что это... Ну да. Ну что, я неправильно говорю, что ли? Да. Да. Долгий, наверное, долгий период. Да. Просто ты не можешь правильно распорядиться, правильный пример показать. Выстроить, как бы, не выстроить, чтобы под тебя выстроили, потому что ты голова в семье, понимаешь? Да, ты, понимаете, да. Типа того можешь спасти разрешение, да. Ну, да. Ну, наверное, вот по этой причине и не только по этой. Потому что ты знаешь этот мир, ты защита для всех страна, да. Да. Человек, да. Одеваться некуда, все равно мужчина, понимаешь? И всю жизнь так. Постепенно как-нибудь. После пятых так не будет. Ладно. Ну, надо там... Ну, вот нет, вот это, а что мне прикажешь? Прикажешь мне бить? Держи лицо, не наверное. Ну, не надо, это все лишнее. Не освоили.
Major neurotransmitter. Cortisol, we've talked about already. Insulin is involved in diabetes, which is involved with adipose tissue and fat. And then, of course, just overall metabolism regulation, which is going to vary depending on the time of day. So it's really important that the circadian rhythm is in sync and is well regulated.
Как делают кашемировый свитер? Кашемир – самый мягкий натуральный текстиль, получают от кочевых скотоводов в монгольских степях. Роскошный текстиль на протяжении веков. Кашемир сохранил свою привлекательность и по сей день. Положенная в самом сердце Центральной Азии, Монголия уже одним из ведущих производителей качественного кашемира. Долгие холодные зимы Монголии способствуют росту изысканно мягкого, теплого подшерстка у кашемировых коз. С приходом весны пастухи-кочевники осторожно расчесывают кашемир от коз, которые естественным образом начинают сбрасывать это мягкое волокно. Голуби получают этот кашемир непосредственно от скотоводов по всей Монголии.
And you asked about consequences. There's been a number of studies that have been done both men and humans that when they apply the dysregulation of the circadian rhythm in rodents, you can see problems with body temperature, increased fat, altered immune system, tumor development, and basically just perturbations of the hormonal homeostasis. In human beings, when they do this prospectively, they show that there are problems with insulin regulation and norepinephrine, and also increased markers of inflammation and diabetes. So there's a lot of problems when you have dysregulation of the circadian rhythm.
You mentioned leptin. What is that?
Well, leptin is a hormone that regulates your hunger. There's two hormones there. There's leptin, which makes you
viewing bright light at night. And the second question is dim light melatonin onset. Is it actually the light that stimulates melatonin release, or is it just the absence of viewing bright lights that actually stimulates melatonin release?
Yes, both good questions. Dim melatonin onset is kind of a bad name for it because really it's the absence of light that allows the pineal gland to stimulate and produce and serotonin throughout the blood and the human body. You're right that it may not be right, and that's the problem, is this circadian rhythm has to fit onto reality. This is a clock that's going on inside your body, but the problem can come in. Your clock is not in tune with what reality is on the outside. In other words, there's a certain part of your body, your circadian rhythm, that's attuned to when you should be awake. And if it's not correlating with when the sun is up, you might have some problems. So yes, which is very finely regulated in the body. But the question is it actually in line with happening outside the body, what reality is? And that's the question.
You mentioned that it's key that our internal clock, our circadian rhythm, is optimally aligned with reality. And that there's all kinds of potential benefits or consequences to that. What are some of the specific things that our circadian rhythm regulates?
Well, if you look at this list, this is pretty extensive, Kyle. I mean, circulating melatonin, we know as an antioxidant. There's studies that suggest that it can reduce cancer. It reduces cortisol production, which is what you don't want to have at night, which is good. It's an antioxidant, and it promotes sleep. That's just the melatonin aspect. But the circadian rhythm also is used in regulation with peripheral clocks, the feeding and the fasting rhythms, right? So you're not typically eating at night, you're eating during the day. And so those are coordinated. We have hormones that go throughout the body like cholecystokinin, leptin, and ghrelin. These are involved with diet. These are involved with being hungry and with being satisfied. Body temperature, glucose metabolism, the pancreas, and you can see some of the other ones there. Vasopressin, which is a blood pressure hormone that determines when your blood pressure should be high and when it should be low. Obviously, you want it lower at night when the body is resting. Acetylcholine is a very major neurotransmitter. Cortisol, we've talked about already. Insulin is involved in diabetes. Adiponectin, which is involved with adipose tissue and fat. And then, of course, just overall metabolism regulation, which is going to vary depending on the time of day. So it's really important that the circadian rhythm is in sync and is well regulated. And you asked about consequences. There's a number of studies that have been done both in rodents and in humans that when they apply the dysregulation of the circadian rhythm in rodents, you can see problem body temperature, increased fat, altered immune system, tumor development, and basically just perturbations of the hormonal homeostasis. In human beings, circadian hormone that creates, you can see some of the other ones there. Vasopressin, which is a blood pressure hormone, which is good, antioxidant, and it promotes sleep. That's just the melatonin aspect. But the circadian rhythm also is used regulation with peripheral clocks, the feeding and the rhythms, right? So you're not typically eating at night, you're eating during the day. And so those are coordinated. We have hormones that go throughout the body like cholecystokinin, leptin, and ghrelin. These are involved with diet. These are involved with being hungry and with being satisfied. Body temperature, glucose metabolism, the pancreas, and you can see some of the other ones there. Vasopressin, which is a blood pressure hormone that determines when your blood pressure should be high and when it should be low. Obviously, you want it lower at body's resting. Acetylcholine is a very major neurotransmitter. Cortisol, we've talked about already. Insulin is involved in diabetes, which is involved with adipose tissue and fat. And then, of course, just overall metabolism regulation, which is going to vary depending on the time of day. So it's really important that the circadian rhythm is in sync and is well regulated. And you asked about consequences. There's been a number of studies that have been done both in rodents and in humans that when they apply the dysregulation of the circadian rhythm in rodents, problems with body temperature, fat, altered immune system, tumor development, and basically just perturbations of the hormonal homeostasis. In human beings, when they do this prospectively, they show that there are problems with insulin regulation, leptin, and norepinephrine, and also increased inflammation and diabetes. So there's a lot of problems when you have dysregulation of the circadian rhythm.
You mentioned leptin. What is that?
Well, leptin is a hormone that regulates your hunger. Hormones there's leptin, which makes you feel satisfied, and there's ghrelin, which is your need for food. You feel more hungry, basically. And so when you're not sleeping at the correct time, when your circadian rhythm is off, you're going to feel hungry and probably eat more food. If you have too much ghrelin or not enough leptin, you're going to also feel hungry and eat more food. There's a problem there when your circadian rhythm is not in sync.
So again, you've mentioned the importance of matching our circadian rhythm with what's going on outside in the world. So how do we do that? What are some strategies that allow us to do that effectively?
But what you have to understand is that the body is hardwired to be able to take information from the environment to change its internal circadian rhythm, that it's in sync with the environment. The slide here tells exactly how that happens. So as you can see here, when light hits the eye and specifically goes to the retina, and I want to specifically say that we know that light that goes to the retina is hitting rods and cones. Those go to neurons, which then project back here to the occipital lobe, and that's where we actually can understand and visualize and see things. What I'm about is a completely different section of the retina, and it does it in a complete way. The first thing you have to understand here is that there is light that we see that we can see. What I'm about to talk to you about is light that comes into the eye that goes to a completely different part of the brain, and it's not light that you're conscious of. It's light that you're unconscious of, and that's important to understand. This light that's coming into the eye is not going to rods and cones, but instead this thing called intrinsically photosensitive retinal ganglion cells. Now these are ganglia. They are in particularly in the inferior portion of the retina at the back of the eye. And that's important to understand because usually light that comes from the superior visual field, when it hits the lens, is going to be projected down into the inferior retina. So this is going to be stuff in the superior visual field. It is then projected to something called the suprachiasmatic nucleus. Now this is the master clock. This is the portion of the brain that everything is working in sync. This is the conductor of that orchestra that I showed you at the beginning. When light comes in, it's telling the suprachiasmatic nucleus that it is daytime, that it is during the day, that this must be coming from the sun. This is how we are hardwired. And because of that, there is a specific neuron that shuts the pineal gland of melatonin. And so light coming into the eye goes to the intrinsically photosensitive retinal ganglion cells. That's a long word there. And it gets projected not to where you would actually see consciously, you would see light, but rather to the suprachiasmatic nucleus, which tells it that it's daytime, and therefore tells the pineal gland, do not make melatonin, because melatonin in the blood system is a signal to the cells that it's nighttime and it's time to go to bed. And so this is how the system, the circadian rhythm, understands that it is daytime versus nighttime. Now, there's actually more to this because obviously it's possible for you to be out of sync. So the question then becomes, how does the brain and the circadian rhythm inside your brain adjust to reality? So I want to show you how the circadian rhythm in your brain can be shifted one way or the other depending on the external sources of light. So I want you to imagine that you're on a desert island, that you have no sort of extrinsic sources of light. You're perfectly aligned. You can see here that the night of the circadian rhythm is actually aligned with night, which is reality. And also the daytime is perfectly aligned with reality, which is day. That's the ideal. In our situation, if we were to, for instance, expose our eyes to a screen or our iPhone, what could happen is that we would start to expose our eyes to light at a time where we would not normally be experiencing light. And so what the circadian rhythm wants to do is it's thinking that it's still daytime. And as a result of that, it's going to shift itself over to that to encompass and capture that because it thinks that it's too early. And so you can see here that exposure at night after the sun goes down, tendency to delay your circadian rhythm. Now that can cause problems, as we talked about before. But the biggest problem that you might notice yourself is that even though you're at night here, your circadian rhythm is not ready for sleep. And so you might actually get the symptom of insomnia. Hey, here at the beginning, and you're still in the middle of your insomnia in the morning. And you can see here that it's important to understand that avoiding light, especially late in the circadian rhythm, after the sun has gone down before you go to bed, avoiding it can prevent this type of shifting from occurring. Interestingly also is exposing your eyes here in the beginning of the day can help anchor your circadian rhythm and prevent it from sliding later and later because of viewing of light in the late hours. I will say that making sure to expose your eyes to bright light in the morning is not a substitute for avoiding bright light in the evening.
Okay, to summarize, if I get good sunlight in the morning, that can help anchor my circadian rhythm to reality. And then if I avoid a lot of light or screen time in the evening, that can help kind of reaffirm to my circadian rhythm that it's time to wind down, it's nighttime, and time to start stimulating melatonin release. Do I have that right?
Yeah, you have it exactly right. And I would add a little bit more to that. A couple things that you should be aware of is that if we go back to this master clock picture again, you'll notice that light is coming in and it's the interior portion as we talked about. So it's really important to avoid bright light, especially up in your visual field. So ceiling lights, things of that nature. I would say if you have to using lighting on the floor or using lighting low on the wall, those night light types of things would be much better. Also realize that the peak sensitivity is intrinsically photosensitive retinal ganglions around 460 to 484 nanometers, which is basically in the blue section. Now, you may have heard of blue blockers, and even programs on your screens and computers that can reduce the amount of blue light, because this is the type of light that specifically is going to excite those intrinsically photosensitive retinal ganglion cells. But Kyle, just to be perfectly honest, it's any kind of light that's really stimulated. It's just this blue light that seems to be the worst at stimulating those ganglion receptors. And remember, when they do, they're going to tell the suprachiasmatic nucleus, as we've shown here, to shut down melatonin production. And the point is that melatonin is the coolant that makes sure that the engine is running smoothly and that antioxidants are kept to a minimum. So you really want to have that melatonin production at night, and you don't like shutting it down.
You mentioned not suppressing the release is key for the antioxidant effect, but it also seems key just to initiate sleep, right? Doesn't melatonin have tremendous benefit in initiating sleep for us as well?
Yes, it does, actually. And many people take melatonin as a supplement orally to help with that as well. But generally speaking, you don't need to have a melatonin supplement to have the onset of sleep. And that's because our pineal gland makes melatonin and secretes it, and it's a message to the body. This melatonin goes throughout the entire circulatory system, and it tells the cells to them that it's time to go to sleep. And melatonin production, as you say, is a signal for sleep.
There's a lot on this slide that I want to ask you about, and I think it's super interesting that the angle of light, not only the intensity of light, but the angle of light has an impact on whether our melatonin is released and ready for sleep or not. And presumably, is this because we've evolved as humans to, if anything, be around fire at night? And that might also explain why the peak sensitivity for blocking melatonin is between 460 and 484, which is that blue light spectrum. So in theory, low light that's predominantly red light, far away from that blue light spectrum, should not inhibit that melatonin too much. Is that right?
It does seem as though a fire was made specifically, or maybe we were made specifically for the fire, because if you notice, a fire is generally away from blues and more into the reds and the oranges, and it's usually in front of us, it's down low. And so that's exactly where we would expect to have the least impact in terms of melatonin secretion or not at night. So in other words, a fire sitting in front of you, it's going to be reflecting on the superior retinal ganglion cells, where there's not a lot of these intrinsically photosensitive retinal ganglion cells. And so the melatonin production should still stay relatively good. And also, as we mentioned, fire is typically red, oranges, and not the type of thing that we would see with blue light, etc. Interestingly also, is at sunset, when we see sunset, the sun is going down, typically the sun is reddish, it's orange, we're not getting a lot of that blue light. And so it's almost like the body is getting ready for sleep. Melatonin is starting to come on, depending on the time of day. Very interesting dichotomy that we see there with fires versus blue light. Dr.
Все хорошо. Готовлюсь к защите диплома. Ой, кстати, я прошла обучение в открытии инвестиций. Пробую инвестировать в биржевые фонды. Но пассивный доход еще никто не отменял.
А это недорого?
Нет. Это как, не знаю, купить пакет молока. Можно инвестировать от 100 рублей, а можно купить ценные бумаги отраслей на 1000 рублей. Идеально для новичка.
А почему не банковский вклад?
Потенциальный доход выше, чем по вкладу. В любой момент можно пополнить или продать. Налоговые льготы. А еще выгоднее открыть инвестиционный счет и получать гарантированно до 52 тысяч рублей ежегодно от государства.
Поняла. Вижу, что ты разбираешься. А на каком сайте инвестируешь?
Да все в приложении. Скачай открытие инвестиций и попробуй сама.
Открытие инвестиций. Любые цели достижимы.
Dr. Schwell, you mentioned blue blocking glasses there, and some people have tried these, many people have heard of blue blockers. basically what they are is a glass that filters out almost all or all of the blue light spectrum. And you mentioned that these aren't a silver bullet, but what would be the consequence of wearing these during the day? If someone's spending a lot of time at their computer for wearing blue blocking glasses, would that have, what type of effect would that have on someone?
Well, because those intrinsically photosensitive retinal ganglion cells have their peak sensitivity in the blue region, and because you want to have as much stimulation to those retinal ganglion cells as possible, to see your chiasmatic nucleus know what time of day it is, you don't want to be wearing blue blockers during the day.
And what about at night? So I understand now you gave the analogy of a desert island. If I was on a desert island with no electricity, that would, from a circadian rhythm standpoint, that would probably be optimal for aligning my circadian rhythm with reality. But that's not the reality we live in. Sometimes people need to work late, they need to be on their screens, working on their laptop, or maybe they want to watch a show in the evening. Would there be some benefit to wearing a blue blocking glass, or potentially using a program on your phone that dims some of that blue light spectrum?
Because the intrinsically photosensitive retinal ganglion cells are very sensitive, even to non-blue light, the best situation is not to view light at all. The next best would be, if you have to, is to wear the blue blocker glasses to at least get just the most efficacious light for these sensors out. And then the worst case scenario would be to watch it without any kind of blue blockers at all. I would just add, Kyle, that if you are going to have light at night, like we've talked about, have it more reddish in the warm spectrum of light, have it down low, and have it as dim as possible. That way you can maximize your melatonin secretion, and again, keep those engines running cool and not overheating with oxidative stress. And of course, having melatonin secretion for sleep as well.
So are these intrinsically photosensitive retinal ganglion cells, basically the sensors within our eye that sense how much ambient light there is, do they have any other purposes?
Yes, they do. So in addition to projecting to the suprachiasmatic nucleus, which regulates the circadian rhythm, they also project to another part of the brain, which has nothing to do with vision, called the perihabenular nucleus. And as you can see here, it is completely separate from the suprachiasmatic nucleus, but it is involved with mood. And so this is something that we see a lot of in the wintertime when people become depressed. And this is known as SAD, or seasonal affective disorder. This is one of the manifestations of not enough light getting to this area of the brain. Kyle, about 5% of the population get symptoms of seasonal affective disorder. And symptoms appear in these patients about 40% of the year. We typically see it more in females versus males. But when they did a meta-analysis of all of these studies that looked at light in these patients, about 173 studies that were identified, randomized placebo-controlled trials, looking at the DSM diagnosis, and about 20 studies they showed something very interesting, that when they were exposed to bright light at about 3,000 lux hours, so that would be 10,000 lux for about 20 minutes in the morning, and they did it for at least 4 days, they were able to show very conclusively that overall with this meta-analysis, there was an improvement in the seasonal affective disorder with bright light. So in addition to just stimulating your eyes with bright light in the morning, we can talk more about the way that works, another way of doing this is something called dawn stimulation. You can see here on the chart that increasing light exposure automatically in your bedroom from about 0 initially to about 200 to 300 lux over a 1 to 2.5 hour period of time can also improve seasonal affective disorder, as we can see here again with this meta-analysis, where overall effect size on these patients. So it's slowly bringing the lights up, and there's actually lights that you can program to do this sort of thing.
I want to demonstrate what one of these dawn simulation lights looks like, and Dr. Schwell never has to use one of these because he lives down in sunny Southern California. But you can see it's got a 1 on it. Now it's going to 8, 10. So it's got from 1 to 20 for this light. And you can program this so it simulates dawn over an hour or over 2 hours or whatever you want. And this little guy is a light made specifically for seasonal affective disorder. I'll turn this on here. It's really
Да,
bright.
прикинь, вот как на Луне лежит, да. Ну да. Да, да, ну да. Ну, это, ну и что дальше? Да, то есть сила воли, наверное, да. Накладить было бы зачем? Зачем? Ну, понятно. Вот это он имеет в виду. Я тебе говорю, потреблять это вообще не мужское свойство. То есть, ну, он себя так говорит просто. Ну, то есть потреблять просто, да.
This one gives off 10,000 lux as long as you're within 15 inches of the light source. I've
Ну, ты представляешь, какая трагедия, то есть, если организм не отличает у тебя, какой еще организм? Нормальный урод, блин, если он про себя так говорит, да.
20 minutes or so in the morning, working on my computer or reading with this light coming from overhead, and again, being within 15 inches of it. Dr. Schweller, are there any other mental or psychiatric conditions that can be potentially treated with light?
Well, yes, Kyle. In 2017, this paper was published looking at can proper light therapy affect bipolar depression. And this study showed that in 46 patients, which were randomized to placebo versus 7,000 lux bright white light versus 50 lux dim red placebo light, around 12 o'clock to 2:30 in the afternoon, 15 minutes per day, and then building up to 1 hour per day by week 4. You can see here that by week 4, there was a significant increase in the patients that were in remission from bipolar depression. That's a good thing. As the number goes up, that was good. And you can see that as the amount of light that was given to the patient increased after week 4, there was a much higher percentage of patients that were in remission who got the 7,000 lux bright white light.
That's really interesting. Are there any conditions that a dawn stimulating light helps with?
Yes, actually, there was a paper that was published in 2010 that looked at artificial dawn for 2 weeks, 250 lux or 50 lux versus control. And what they saw was a significant reduction in sleep inertia. In other words, it was easier to get up. You weren't feeling like you were tired and you wanted to stay in bed. In the 50 lux and the 250 lux versus no dawn at all. And you can see here that very similar intervention, the dawn stimulating light, when they did this for 30 minutes prior to waking up and then 20 minutes after waking up, compared to a very small amount of light, they were able to show that this dawn simulating light improved subjective well-being, mood, and actually cognitive performance as compared with the dim light and the minimal blue light that they had as controls. I would just say, though, that this artificial light, this dawn simulating light, is really just a way of capturing what you would normally have if you were to go outside and expose your eyes to bright lights outside early in the morning. So all of this is really to show that stimulating your eyes with bright light from the sun is very beneficial.
You mentioned earlier that not only melatonin, but cortisol is key in regulating our circadian rhythm. Can you tell us more about cortisol?
So cortisol comes up early in the morning, usually around 8 or 9 o'clock in the morning, and then tapers off as it goes around to midnight. And cortisol is actually the thing that sets in motion the timing of melatonin about 12 to 14 hours later. So if cortisol is coming up at around 8 o'clock in the morning, then melatonin is going to be coming up at around 9 o'clock at night in a perfectly timed circadian rhythm, as we talked about. But when you have cortisol levels that are not aligned correctly, so your circadian rhythm is off, cortisol pulses that are shifted later in the day can be correlated with conditions of anxiety and also depressive disorders. Also, bright light is a strong stimulus for cortisol levels coming up in the morning. Again, another reason why you want to have bright light stimulation early in the morning when you're getting up, because that allows the cortisol levels to come up, and that's going to time the melatonin levels later in the evening. So remember that cortisol is a very important hormone. It's a steroid hormone. It goes into the cells, goes into the nucleus, and it controls about 20% of the genome of your DNA. And so that if you have chronic stress, also remember that chronic stress increases cortisol levels above what they should be, and that can cause problems on down the road. So you want to have enough cortisol, you want to have it at the right time, and you don't want too much of that cortisol. And so again, another important reason why you want to have bright light exposure in the morning to anchor the circadian rhythm and to make sure your cortisol levels are coming up at the right time.
Introducing Valvax 3 points with 15 features. The world's best travel jacket. Now minimalistic, yet still highly functional. 3 colors that can be dressed up, down, or worn classic. After researching eco-friendly functional fabric, we landed on eucalyptus, sustainably sourced and sustainably made. It's not only environmentally friendly, it's thermoregulated.
I've heard there's been some research about melatonin being connected with cancer rates. Can you talk about that?
Yeah, so the thing that we have to remember is that even a small amount of light can completely shut down melatonin gland. And so if melatonin is the antioxidant and the sleep signal that we need, if it gets shut down, is that going to cause problems? We talked earlier that potentially some of the problems are related to cancer. And so there's been some research on this, and it has been associated with the increase of cancers, specifically breast cancer, and specifically the type of breast cancer that is not responsive to hormonal therapy. There's been also some other research that has gone into this, and the WHO has classified circadian disruptive shift work as a probable carcinogen because of this connection. Interestingly, in patients who have become blind because of the severing of the optic nerve, remember, not only is the rods and cones sending neuron axons through the optic nerve, but also these intrinsically photosensitive retinal ganglion cells send their axons through the optic nerve. And so, ostensibly, if you were to have these things severed, there would never be input to the suprachiasmatic nucleus to shut down melatonin production at that time rhythm. And what they've actually found in some studies is that there is a reduced cancer risk in totally blind people. There was a relative risk of 0.69, meaning that they were 69% as likely to get cancers as people who were not blind. And again, with these studies, we'll go ahead and put links in the description below so you can look at these studies yourself.
So we spoke earlier about how important it is in the evening, once the sun goes down, to dim lights. If you're going to have lights, try to have them below the level of your eye, avoiding bright screens. If it gets dark pretty early, like it does in Oregon, where I live, the first thing I would think of doing is reading more at night. And I have an e-reader. A lot of people read on their iPhone or their tablet. So what is the consequence of doing this? And if we can't use e-readers, what should we use?
Yeah, so you can imagine a book using a light bulb reflecting off of a regular book, print book, versus an iPhone or an iPad or an e-reader. What would you think that they would be about the same? You know, there was a paper that was published in 2015 that looked at that very question. As you can see here, what they measured was the irradiance of the ebook versus the print book. And you can see here we have irradiance on the y-axis, and we have it broken down into wavelengths. What we have top is the book, and you can see clearly that in the blue range, there's quite a lot of irradiance at that point. The hard time seeing is because it's so low, is looking at a print book in light, and you can see clearly in the irradiance in the ebook and the regular print book. So again, it would be better for you to read at night using a regular print book than reading off of your iPhone, iPad, or an e-reader.
what is spectral irradiance? And the other question I have is, did it matter in the study whether the light source for those using a regular book, not an e-reader, was LED light, or incandescent, or something else, or what did they use in the study?
So in the study, they simply said very dim light. So they didn't mention if it was an LED light or an incandescent bulb. But in terms of irradiance, as you can see there from the units, are microwatts per square centimeter. So that's basic energy there is, and it's very similar to what we would say lux would be.
Okay, so this study established that there's more light energy, significantly more, coming towards the eye from an e-reader as opposed to just a regular book with dimly lit room. Did that have any consequence on someone's sleep or their health?
Well, if you look at sleep latency, which is the time it takes for somebody to fall asleep, you'll see that it was much longer in those who were watching the ebook than those who were reading the book in dim light. In the study, it also showed that those subjects that were reading with the ebook felt more sleepy the next day when they got up. In other words, they had more sleep inertia.
Okay, Dr. Schwell, to summarize, can you give some specific recommendations for optimal light viewing and avoiding light in the evening?
Yeah, so let's summarize exactly what the recommendations are. Number one, in the morning, view sunlight as soon waking up as possible, ideally before 9 o'clock in the morning. There's nothing better than going outside. The sun is coming up. There's much more outside than you're ever going to be able to generate inside. But if you're where the sun is not up, where it's very cloudy where you live, you can aim for about 10,000 lux, spend about 20 to 30 minutes a day in the morning. You want to be anywhere between 11 and 15 inches from the light box. So that's one option, but again, nothing beats actually going outside. Remember when we talked about lux, that on a bright sunny day, it's about 100,000 lux. You can get that very, very quickly. Remember that the photoreceptors in the retina in the morning are not very sensitive. So you need to have very bright light to activate it, but it's kind of integrated over time. So if it's not very bright, you have to spend a longer amount. If it's very bright, then you don't have to spend much time at all. If you're in very bright light, 30 seconds may be all that you need if it's 100,000 lux. On a cloudy winter day, like we were just talking about, it could take up to 30 minutes. But again, making sure that you're getting your eyes looking at bright light in the morning. You want to avoid sunglasses. You want to avoid windows. And we'll talk a little bit more about this, but especially the low E glass. That's very effective at filtering out infrared light. You don't want windshields. That doesn't really count. You want to get outside and have nothing between you and the light source. Again, avoiding blue blockers. We talked about how blue light stimulation is really key at that time of the day. So make sure that you're getting as much stimulation as possible. In terms of what you should do in the evening time, after the sun goes down, is to limit as much light as possible after sunset. You want to have any kind of light that you have as low as possible. You want to have it as red as possible. And you want to have it as dim as possible, so that you can have the benefit of melatonin secretion from the pineal gland when the time is right. Remember what we said, that intrinsically photosensitive retinal ganglion cells are more activated by blue light. So if you have no choice, if you have to do something, it's better to make sure that the blue light aspect is reduced, either by programming it into the computer or by wearing blue blockers, glasses. That really is the two aspects of this portion of the talk, where we talk about how light interacts with the human body in a circadian rhythm way. What should you do in the morning? Number one, sunlight before 9 o'clock, anywhere between 30 seconds and 30 minutes, depending on how much sun there is, because remember that these intrinsically photosensitive retinal ganglion cells are not very sensitive in the morning, so it takes time. But the good news is that there's integration, which means that the more time you spend, the more activated they're going to be. So if there's bright sun, it might only take 30 seconds. But if it's cloudy, if it's a dim day, if you're getting up early before the sun comes up, it might take as much as 30 minutes. So because of that, you don't want to be wearing sunglasses. You definitely don't want to be wearing blue blockers, because blue light is really good at this point. You don't want to be behind a window or a windshield. It's okay to have glasses or contacts. Because if you do, if you wear the sunglasses, if you're behind the window or the windshield, it's going to take a lot longer to get the stimulation that you're going to need otherwise. The other option is you do it inside and you get this 10,000 plus lamp that has 10,000 lux, and spending about 20 to 30 minutes in the morning, about 11 to 15 inches away from the light box, is going to be what you need to really anchor and to get the light stimulation that you need, to get the cortisol secretion that you need, and also the melatonin timing, and to really set the circadian rhythm right. Now, to keep that going, what are you going to do in the evening? Really, it's this basic, understanding that photons, light that's going to the retina is going to shut down melatonin production. You really want to have the lights as dim as possible. If you do have lights, have them as low down in your environment as possible, because we talked about that light down low around the floor, lower part of the walls is not going to stimulate the suprachiasmatic nucleus as much and therefore shut down melatonin production. And then again, if you have it more towards the red aspect of the spectrum, yellowish, reddish, that type of thing, then you're also not going to shut down melatonin production. Think about fire. It's low down, it's dimmer, and it is redder. Those are the types of things that are going to be beneficial for you at night.
Если вы планируете открывать кофейню, в первую очередь вам нужно зарегистрировать ГУБАЕВ. Мы это сделаем там абсолютно бесплатно. После открытия расчетного счета вам нужно будет подключить онлайн-кассу.
I would have thought that sitting in front of a window with full sunlight coming at me through the window would be almost as good as being outside. Or if I'm driving in my car, on my way to work or whatever it may be, if I'm driving right at the sunlight, it seems like that would suffice. But you're saying that there's a huge difference between actually being outside doing light and being behind the window. Do I have that right?
Yes, you do have that right. So if we look here at a family living room, ostensibly with windows, you're talking about 50 lux in terms of intensity versus an overcast day, which you would think about the same, that's 20 times higher in intensity at 1,000. And that's so going full daylight and even direct sunlight, much, much higher. We really have a poor sense because our pupils adjust and our eyes adjust to light when we go inside versus outside. Outside, there is tremendously more lux in terms of light than there is.
If anyone wants to play around with how lux is in their environment, whether it's outside, there are a variety of apps for your smartphone of choice. Some of them involve actually creating a white piece of paper and creating a filter for your light sensor on your phone, but the amount of lux in your environment at home so you can get a sense of where you are.
So this is the second part of our talk where we talk about how light interacts with our bodies and mitochondria that I referred to at the beginning. This is really interesting. It was mind-blowing when I first learned about it, and I imagine that most of you out there probably have not heard this before. So as we talked about, the mitochondria are the portions of the cell which are the powerhouses. They make energy and they make ATP similarly to how an engine in a car makes locomotion. But the problem is with locomotion, heat is generated around the engine, and that heat can stand to shut down the engine if it's not dealt with in an appropriate way with a cooling system. Same thing with the mitochondria. The byproduct of making energy is oxidative stress. And as we talked about before at the beginning, let's review a little bit. The mitochondria, if they're not cooled down, to use the analogy, oxidative stress can happen. And oxidative stress can lead to less optimal health, inflammation, cancer, dementia, diabetes, and even learning disabilities. And as we'll talk about later, it's been implicated with COVID-19 mortality. So how does the body deal with this? As we talked about earlier, we know that at night, melatonin is secreted from the pineal gland, normally, if the person is not being exposed to light, and this melatonin is actively secreted and actively taken up into the cell, and then it goes into the mitochondria, where it is the major antioxidant. It actually is the one that controls glutathione. It's twice as potent as vitamin E. But the question is while this is happening at night, that's great. But what happens during the day when more energy is needed and essentially these mitochondria are revving up at higher RPMs? What happens then? Well, scientists are now discovering that infrared radiation from the sun actually directly stimulates the mitochondria to produce melatonin on site where the oxidative stress is occurring. Now, this is not from eating melatonin or taking a supplement. This is actually from the sun itself, penetrating down into the tissue, stimulating the mitochondria to produce melatonin. There was this very interesting paper that was published by Scott Zimmerman and Russell Ryder, one of them a professor and the other one a light engineer, that described this, and I would highly recommend looking at this article. I'll put a link in the description below. But what they said in this article, and these are the highlights, is that melatonin, we know, is a potent antioxidant, and that it's actually produced within the mitochondria in response to sunlight and provides targeted protection of the mitochondria from reactive oxygen species. It's also protective against a wide range of diseases that are identified with mitochondrial dysfunction, including cancers, neurodegenerative diseases, cardiovascular disease, and also diabetes. And it may have a role in the prevention of diabetes, Alzheimer's disease, Parkinson's disease, and even, as we'll talk about, COVID-19. So let's take a little bit more closer look at what's going on in the mitochondria and why this is happening. So let's talk about what's going on here. You have to understand that all of the cells in your body have things called mitochondria. And the mitochondria are these powerhouses or power plants inside the cell that make energy. And the product of that metabolism is something called ATP. And ATP is the molecule of energy for the cell. So let's take a look at the mitochondria in a little bit more detail. So if we look at mitochondria, there's an outer membrane, and the problem is with locomotion, heat is generated around the engine, and that heat can stand to shut down the engine if it's not dealt with in an appropriate way with a cooling system. Same thing with the mitochondria. The byproduct of making energy is oxidative stress. And as we talked about before at the beginning, let's review a little bit. The mitochondria, if they're not cooled down, to use the analogy, oxidative stress can happen. And oxidative stress can lead to less optimal health, inflammation, cancer, dementia, diabetes, and even learning disabilities. And as we'll talk about later, it's been implicated with COVID-19 mortality. So how does the body deal with this? As we talked about earlier, we know that at night, melatonin is secreted from the pineal gland, normally, if the person is not being exposed to light, and this melatonin is actively secreted and actively taken up into the cell, and then it goes into the mitochondria, where it is the major antioxidant. It actually is the one that controls glutathione. It's twice as potent as vitamin E. But the question is while this is happening at night, great, but what happens during the day when more and essentially these mitochondria are revving up at higher RPMs? What happens then? Well, scientists are now discovering that infrared radiation from the sun actually directly stimulates the mitochondria to produce melatonin on site where the oxidative stress is occurring. Now, this is not from eating melatonin or taking a supplement. This is actually from the sun itself, penetrating down into the tissue, stimulating the mitochondria to produce melatonin. There's this very interesting paper that was published by Scott Zimmerman and Russell Ryder, one of them a professor and the other one a light engineer, that described this, and I would highly recommend looking at this article. I'll put a link in the description below. But what they said in this article, and these are the highlights, is that melatonin, we know, is a potent antioxidant, and that it's actually produced within the mitochondria in response to sunlight and provides targeted protection of the mitochondria from reactive oxygen species. It's also protective against a wide range of diseases that are identified with mitochondrial dysfunction, including cancers, neurodegenerative diseases, cardiovascular disease, and also diabetes. And it may have a role in the prevention of diabetes, Alzheimer's disease, Parkinson's disease, and even, as we'll talk about, COVID-19. So let's take a little bit more closer look at what's going on in the mitochondria and why this is happening. So let's talk about what's going on here. You have to understand that all of the cells in your body have things called mitochondria. And the mitochondria are these powerhouses or power plants inside the cell that make energy. And the product of that
metabolism is something called ATP. And ATP is the molecule of energy for the cell. So let's take a look at the mitochondria in a little bit more detail. So if we look at mitochondria, there's an outer membrane and there's an inner membrane. The center we call the matrix. And the space around it we call the intermembrane space. Let's zoom in a little bit and take a better look at what's going on there. Here we see the intermembrane space, and here we see the matrix. In the matrix, we have something called cycle. Krebs cycle, carbohydrates, proteins, and fats are metabolized, and they enter into Krebs cycle at various different pathways, and they come from, obviously, the outside of the cell. The major byproduct of Krebs cycle is something called NADH. In addition to NADH, there's a small amount of ATP and GTP and other reducing agents, but the major product of Krebs cycle and the metabolism of carbohydrates, proteins, and fats is to make NADH. Now, NADH is a way of packaging very powerfully reduced electrons. So what's interesting now is how the mitochondria take these very reduced electrons and convert them into energy. And that's done with something called the electron transport chain. The electron transport chain. And the electron transport chain is basically a series of drops, almost like a dam, that goes through this electron transport chain. And at every step along this way, the energy from those reduced electrons from the NADH is coupled with a pump that pumps protons out into the intermembrane space, so that the amount of protons in the intermembrane space start to increase. And this occurs successively as the electrons are passed down step by step by step, until finally all of the energy is extracted from these electrons. And the final electron acceptor is something that we all need, and that's oxygen. And this is the reason why we need oxygen when we breathe, is we need an acceptor of those electrons. So this is where oxygen is required. Now, this is very important for you to understand. Finally, at the very end of this electron transport chain, there's an enzyme known as cytochrome C oxidase, or CCO for short. That takes this oxygen molecule and makes a water molecule out of it by passing on those electrons to this oxygen molecule. The problem is that when this stuff starts to go and these wheels start to turn, if you will, and these electrons start to be passed down the chain, it's not perfect. And sometimes you can have these electrons getting caught up with other oxygen molecules and something called reactive oxygen species being made. The most common one here being superoxide. But there are other ones as well, such as hydrogen peroxide and also hydroxy radicals. All of these are very dangerous substrates that can interact with the proteins around them and can cause severe damage. And the more damage they cause, the more likely there is to be more reactive oxygen species made. So it's very important that if and when these reactive oxygen species are made as a result of metabolism and this electron transport chain, that they get mopped up. More about that in just a second. But first, let's go back and talk a little bit about what happens with all these protons. So these protons start to build up, and then what occurs is finally there is a protein here that sits in the intermembrane space known as the FATPase. And simply what happens here is the protons go down their concentration gradient back into the matrix, and what you have is ADP becoming ATP as these protons go down their electron gradient. And here you have the product of this whole thing, which is ATP, which is, again, the high energy product of this entire process of metabolism. So you go from having carbohydrates, proteins, and fats into making ATP. In the process of this, you do need to use up oxygen. More importantly for our discussion today is you can't help but make reactive oxygen species. Well, the way that the body has of mopping this up, or making sure that these things go away, is through melatonin. So there is, of course, melatonin outside the mitochondria, outside the cell, that can come in
and mop up these things very quickly because melatonin is a very powerful antioxidant. But now we're finding out that specifically this last enzyme that we talked about, cytochrome C oxidase, which takes this oxygen molecule and makes it into water and makes this process go well. When this enzyme, cytochrome C oxidase, is excited with a certain wavelength of light, specifically infrared light, it actually increases melatonin production inside of the mitochondria. That's right, melatonin inside the mitochondria as a result of the activation of this electron transport chain, which can then neutralize the product of the electron transport chain, which is not only water, but in certain cases, oxygen, as we mentioned, mixes with these electrons inadvertently, making these reactive oxygen species. Now, these reactive oxygen species, as we mentioned, are very dangerous, and they have to be dealt with on site because they react very quickly to products around them and can oxidize them and damage them. And as these things become damaged, they cause more oxidative stress and more mistakes and more superoxides and hydroxyperoxides and hydroxy radicals. And there are certain diseases associated with this, as we mentioned, Alzheimer's disease and Parkinson's. These are all situations where the mitochondria are not acting appropriately. And we can talk about a number of other diseases that are also in line with this.
So what you're saying, Dr. Schwal, is infrared radiation from the sun stimulates something called cytochrome C oxidase. And that in turn tells the mitochondria in all of our cells to stimulate melatonin production?
In fact, this is not very well known because this production of melatonin, Kyle, is happening inside the mitochondria. It's taken us a lot of time and energy and technology to be able to detect that type of level. Where we first detected melatonin was in the blood, and that's the backup plan at night. But what we're starting to find out is that melatonin production in the mitochondria is actually the front line cooling system for the mitochondria. As you can see here on this slide, less than 5% of the body's melatonin is produced in the pineal gland, and greater than 95% of the body's melatonin is produced on site in the mitochondria. This is a quote from Zimmerman and Ryder. He says, "It has now been shown that the mitochondria produce melatonin in many cells in quantities which are orders of magnitude higher than that produced in the pineal gland. This subcellular melatonin does not necessarily fluctuate with our circadian clock or release into the circulation system, but instead goes to be consumed locally in the mitochondria in response to free radical density within each cell, in particular in response to near infrared." There's more to this quote, so bear with me. I'm going to go on here. Basal and biological review of the literature, it is proposed that the near infrared portion of natural sunlight, and we'll define that, stimulates an excess of antioxidants like melatonin in each of our healthy cells, and that the cumulative effect of this antioxidant reservoir is to enhance the body's ability to rapidly and locally deal with changing conditions throughout the day. In this approach, the role of the circulatory melatonin produced by the pineal gland is to provide an efficient method of delivering supplemental melatonin during periods of low cellular activity, that would be at night, and solar stimulus to damaged or aging cells in both diurnal and nocturnal animals. While circulatory melatonin may be the hormone of darkness, in other words, the pineal gland at night, provided that there's no light hitting the retina. However, subcellular melatonin, that is intramitochondrial melatonin, may be the hormone of daylight. In other words, this intramitochondrial melatonin is a result of the person going out into the sunlight, specifically infrared radiation.
Question, Dr. Schwal, subcellular melatonin that is produced within the mitochondria of our cells during the day, does that have any effect on us feeling sleepy?
Совкомбанк возвращает проценты по кредитам. Платить 0 усилий 3 миллиона. Кредит на крупные суммы от Совкомбанка. Быстрое онлайн-оформление. До 3 миллионов в тот же день. Совкомбанк. Для оформления просто перейдите по ссылке.
Я сделал шокирующее открытие. Наша Луна сошла с орбиты.
Мы имеем дело с разумной сущностью. И планируем атаковать эту штуку. Очень нужна твоя помощь.
Скажи да, Брайан.
Падение Луны в кино с 3 февраля.
Not at all. So this is inside the mitochondria. And this is the reason why, to get this effect, you really can't take oral supplementation, because oral supplementation is going to go into the circulatory system eventually. And that's going to send off a whole bunch of signals to cells to tell them that it's time to go to sleep. This intramitochondrial melatonin is doing the job inside the cell, and it has nothing to do with sleep at all.
And to clarify, the primary way to get that is from natural sunlight.
Then we'll talk about other ways you could potentially get that as well.
Infrared light coming from the sun, and specifically near infrared. Can we go back to that spectrum chart that you had that showed all the sun's energy? Can you explain near infrared in more detail?
Yes, so near infrared is just a aspect of the entire spectrum of light. Here we see the solar spectrum, and we're specifically looking at near infrared radiation. That is the part from 760 nanometers to 1400 nanometers, and you cannot see this. How you experience near infrared radiation or light from the sun is a feeling of warmth, and that is because this type of light from the sun can penetrate deep into the epidermis, the dermis, and even the subcutaneous tissue, depending on the wavelength, and is perceived as heat because the transfer of this energy actually stimulates the heat receptors in our skin, and that is how it is felt. You'll often feel this, right? If you're in the sun and your back is to the sun and you've got a shirt on, you'll feel that warmth on the back. That is infrared radiation speaking to you. Why is it able to penetrate through clothes? It's actually able to penetrate quite deeply. Kyle, have you ever pulled up to a stop sign and a bunch of teenagers in a car pull up to you and they turn on their radio? What do you hear? All you're hearing is the boom, 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 right? That's the low frequency sound. That's because low frequency or long wavelength energy can penetrate through things fairly easily. And so that sound is penetrating their car, going across into your car, and it's vibrating your steering wheel. And that's because this type of light, this infrared, and specifically the near infrared energy, can penetrate very well through the atmosphere. It can penetrate very well all the way down through your clothes and into your skin and actually deep into your body. And it's able to have the effect that it has on many of the cells in your body as a result. So the purpose of this slide is to demonstrate that the majority of the energy coming from the sun and hitting the earth is in the infrared spectrum. Here we have infrared on the right side of this black bar. We have the visible spectrum here, and we have ultraviolet over here on the left. And as you can see, if we look at the red envelope here, you'll see that this is the amount of energy that's hitting the earth in the visible spectrum, but all of this red over here, and specifically right up to about 1400, all of this is the amount of energy that is coming through the atmosphere, hitting the earth in the infrared spectrum. So we're dealing with a large amount of energy. If we look at that energy as it hits the skin, notice that wavelengths that are longer tend to penetrate more deeply. The interesting thing about this is that infrared, which is out here, or specifically near infrared, can actually penetrate down, it is estimated, depending on which study you look at, anywhere from 1 centimeter up to 8 centimeters. And as you know, 1 centimeter is twice 5 millimeters. So you can see how deep this could actually go.
So does wearing sunscreen block infrared radiation into our skin?
While sunscreen and sunblock is very good at blocking ultraviolet light, it is not very good at all and actually has really no effect on the ability of the sun to radiate infrared and through the skin.
And you mentioned this earlier, but clothing, if I'm wearing a couple layers of clothing or maybe even a jacket, can I still get infrared radiation penetrating into my skin?
Well, it depends on how much you're wearing. So if it's a very large jacket, yes, especially a thermal jacket, because the way we experience heat, infrared is not going to penetrate that very well. But you can put on clothes that would prevent ultraviolet light from causing sunburns and things of that nature, but it would not prevent the infrared radiation from penetrating down into your skin.
So there's a good rule of thumb that if I can feel the warmth from the sun on my skin, I'm probably receiving infrared radiation into my skin.
Yes, that would be a very good indication. So if we look at the paper from Zimmerman and Reiter, what they demonstrated here is that regardless of whether or not the skin is melanin rich or not, you can see here that this infrared light was able to penetrate down up to 8 centimeters into the skin. Some is reflected, but the point here is that infrared radiation can penetrate up to 8 centimeters according to some of their studies, and that is a significant amount in terms of depth and the amount of tissue that infrared radiation can actually affect. If we look at this picture here of a hand in visible light reflects off the surface of the skin, but near infrared light, at in this case 810 nanometers, penetrates down deep enough that it actually shows where the veins are under the surface. And this is actually used in the clinical setting to help nurses find veins. What's going on here is veins and the blood are absorbing the light and not reflecting it back, and that's how you're able to see these veins that are beneath the surface. What they did in their studies, they looked at the number of cells totally in the human body with time. And you can see here that as a child grows, the number of cells in their body increases. In terms of the number of cells that near infrared can reach, because it penetrates so deeply, they were able to show that there's a large amount of cells in the human body that is accessible to near infrared radiation. That as opposed to ultraviolet and visible spectrum, which is down here at the bottom. So near infrared light, even though we can't see it, can penetrate very deeply, and it affects a number of our cells in our body. Of course, as we grow in girth, as we become more obese, for instance, the number of cells that are not able to be reached by near infrared radiation would become more and more. There is a physics of the near infrared radiation that has to be taken into consideration. What was very interesting to me was that near infrared radiation could even penetrate bone. And what they showed here very elegantly was that near infrared radiation can actually penetrate bone, and that the cerebral spinal fluid that surrounds the brain would diffuse the near infrared radiation and would actually cause the sulci and the gyri, these are sort of the dips and the crevasses in the brain, to trap that near infrared radiation and to reflect it down deep into these caverns so that the gray matter on the surface of the brain could be exposed to near infrared radiation.
Dr. Schwab, did I hear you right that sunlight can penetrate bone?
Yes, Kyle, I too was a little incredulous. I will put in the description below an article that actually demonstrates that sunlight can penetrate through the skull. But I remember back, in addition to when I was taking a physical examination course in medical school, and what they showed, and what you'll see here on the screen, is a couple of screenshots from a YouTube video demonstrating the practice of transillumination. This is where on physical exam you try to see whether or not the sinuses are filled with mucus or if they're empty and open like they should be. In this case here on the top left, the examiner is shining visible spectrum light, not near infrared, but visible, into the frontal sinus. And you can see that it illuminates here, and you're able to see that it is completely clear. And that tells you, if you look down here, that is the bone that that light is shining through. And that tells you that the sinuses are clear. Here's another one here over on the right-hand side, except here the examiner is shining light on the maxillary sinus, and it's illuminating, and you can see clearly here inside the mouth. If you look up through the roof of the mouth, you're looking through the maxillary bone, and you can see that it is also transilluminating. So if visible light can go through bone, then you know that near infrared, which has a better propensity to travel through objects, can do it as well.
So what I need to actually out in the sun to get near infrared radiation?
No. In fact, Kyle, what this figure shows is that the light that comes from the sun is very rich in near-infrared radiation. What's even richer in near-infrared radiation is the light that reflects off of the green leaves and the trees and the grass. You see that most blue, green, and red materials have a very high near-infrared reflectance. And so actually what's coming to our eyes is light, especially if you're surrounded by greenery, that is very rich, specifically in near-infrared radiation. So that when we look at the light that's actually coming to the eyes, over 90% of that light that's entering the eye isn't even doing so through the pupil. It's actually going around it because it's able to penetrate through this near-infrared radiation, not only the eye, but also the rest of the body, so that what we're seeing is light that is very rich in near-infrared radiation, and you actually don't even need to be into the sun.
So being outside in green spaces is a good place to be from a near-infrared radiation standpoint.
That's exactly correct, Cal. Near-infrared photographs. You'll see that it's exactly, see that it illuminates down here clear. Here's a map. Know that near-infrared, which has a better propensity to travel through objects, can do it as well.
So would I need to be actually out in the sun to get near-infrared radiation?
No. In fact, Kyle, what this figure shows is that the light that comes from the sun is very rich in near-infrared radiation. What's even richer in near-infrared radiation is the light that reflects off of the green leaves and the trees and the grass. You see that most blue, green, and red materials have a very high near-infrared reflectance. And so actually what's coming to our eyes is light, especially if you're surrounded by greenery, that is very rich, specifically in near-infrared radiation. So that when we look at the light that's actually coming to the eyes, over 90% of that light that's entering the eye isn't even doing so through the pupil. It's actually going around it because it's able to penetrate through this near-infrared radiation, not only the eye, but also the rest of the body, so that what we're seeing is light that is very rich in near-infrared radiation, and you actually don't even need to be into the sun.
So being outside in green spaces is a good place to be from a near-infrared radiation standpoint.
That's exactly correct, Kyle. Kyle, take a look at these near-infrared photographs. You'll see here that it's exactly as I'm talking about. You can see here the leaves, the grass, the plants, they're all bright white, almost like they have snow on them. And that's because they highly reflect near-infrared light so well. Here's a picture in Central Park, and you can see that the buildings are basically...
So being outside in green spaces is a good place to be from a near-infrared radiation standpoint.
That's exactly correct, Kyle. Kyle, take a look at these near-infrared photographs. You'll see here that it's exactly as I'm talking about. You can see here the leaves, the grass, the plants, they're all bright white, almost like they have snow on them. And that's because they highly reflect near-infrared light so well. Here's a picture in Central Park, and you can see that the buildings are basically black because there's no reflectance there of near-infrared radiation, but you can see that the leaves and the trees are highly reflective of near-infrared radiation, and we're not in the sun here at this point. So that is very interesting to me because there's a lot of research, Kyle, that shows that there are health benefits when people are living in green spaces as opposed to concrete jungles. This is a paper that was published in Environmental Research. This is 2018, not too long ago. The title is The Health Benefits of the Great Outdoors, a systematic review and meta-analysis of green spaces and health outcomes. They said, quote, we found that spending time in or living close to natural green spaces is associated with a diverse and significant health benefits. It reduces the risk of type 2 diabetes, cardiovascular disease, premature death and preterm birth, and increases sleep duration. People living closer to nature also had reduced diastolic blood pressure, heart rate, and stress. In fact, one of the really interesting things we found is that exposure to green spaces significantly reduces people's levels of salivary cortisol, a physiological marker of stress. Kyle, did you notice these are the same things that we talked about were the result of mitochondrial dysfunction? Now that green spaces are very good at reflecting near infrared radiation. Take a look. You can see when they looked at all of these studies, this diamond here at the bottom means that when they looked at studies and took the average of the results, because it did not touch this zero line right here, confirming that there was benefit for a subject of this study to be living in green spaces.
So this sounds like a really interesting theory, but do we actually have evidence that near infrared impacts our mitochondria at the cellular level?
So let's take a look at this evidence. This was published in 2016. And what they did here was they took a laser at 64 nanometers, perfectly within the near infrared spectrum. And when they applied it to the skin and measured the concentration of cytochrome C oxidase, you can see that compared to the blue controls, the red laser increased cytochrome C oxidase levels until they laser, and then you can see that it went down. So clearly, cytochrome C oxidase in the mitochondria is reacting to this infrared laser. What they also noticed in the same area of the body was that oxyglobin. Well, so in other words, what we're seeing here is that the amount of blood supply going to this area increased. And as we'll see later, this is increased nitric oxide. So nitric oxide is a vasodilator. It's also been implicated in antioxidant systems. And basically when you have this type of radiation, near infrared radiation, there is an excitation of cytochrome C oxidase that increases the amount of melatonin production. And we know that because of chemical studies that have shown the increase in melatonin relative to the enzyme that produces it, and also from serotonin, where it comes from in the mitochondria. It's also causing vasodilation, more blood coming to that area, and improved oxygenation to that tissue. More on those ends, you can see here that a paper that was published in 2017 titled Near Infrared Light Stimulates Release of an Endothelium-Dependent Vasodilator and Rescues Vascular Dysfunction in a Diabetes Model. You can see here that light in 70 nanometers not only improve nitric oxide, but also cause smooth muscle relaxation. This is what they say in the article. In conclusion, 670 nanometer light energy produces acute ink vessel diameter at physiological pressures through the release of a vasodilator from the endothelium. In vitro experiments report the direct actions of light energy on cultured endothelial cells to produce nitric oxide independently from nitric oxide enzyme activity. Under pathological conditions of nitric oxide depletion, light energy should be considered a viable means for increasing nitric oxide, as evidenced by the significant stimulation of dilation. Thus, the acute increases in dilation observed by light energy suggest that it can provide an effective, non-invasive source for nitric oxide delivery. There have been many studies over a number of years enumerating the benefits of natural sunlight. We now know that radiation, of course, is part of natural sunlight. There have been many enumerated the benefits of natural sunlight. We have codes now in schools that specifically delineate how much light comes through the windows. And back then, when they were making up these codes, those types of windows did not block infrared radiation. So maybe the reason why there was improved outcomes even in schools. You can see here in this table of benefits with natural on students. There's been also a number of specific studies that looked at sunshine. This is a systematic review of sun exposure in type 2 diabetes and their outcomes. Here they looked at 11 different with sun exposure on type 2 diabetes. And you can see here a number of outcomes. The highest evidence in this case was moderate, and it showed that there was a reduction in association with diabetes with direct sunlight exposure. There was another study that was done looking at two different cities in Europe. One was in the Netherlands, the other was in England. And what they did was very elegant. They took a lot of blood tests from these patients, and they were able, using weather reports, to look back over the last 7 days to see if there was a lot of sunlight during those past 7 days before the blood was given. Of course, it was a very large sample, and they were able to see if there was statistical significance between when blood samples were given when it was very cloudy versus when blood samples were given when it was very sunny, just before those samples were delivered. So as you can see here, over 13,000 subjects in the study. And what they showed here is after doing the model, adjusting for age, percent body fat, and also season of the year, and also outdoor temperature to make sure that they corrected for all those, they were able to show that when the percentage of hours of sunlight in the last 7 days got less and less and less, there was worsening in glucose metabolism and also in lipid metabolism in those subjects. So let's talk a little bit about the actual amount of damage that light can do. We talked about all the benefits of light, and we haven't really talked about the damage that light can do. Now, what you see here is a spectrum of light going from the ultraviolet here on the left-hand side, and then the visible spectrum here with infrared going in this direction. As you can see on this graph, which is graphing basically the amount of radicals that are manufactured. So this is basically a graph of oxidative stress from light in the different categories. And you can see here that ultraviolet A is very adept at creating reactive oxygen species and oxidative damage. UVB also being somewhat high, but not as much. And you can see that down in energy in terms of light, the amount of oxidative damage is much, much less. The type of light that you want to avoid is ultraviolet radiation, not so much infrared. It does not cause as much damage. And that's important when we're understanding about when we're going to go out into the sun. What do we do in concerns of melanoma and skin cancer? Well, it's interesting because here was a study that was done, almost 1,000 cases of melanoma, looked at 513 in the population and 174 sibling controls that were recruited in England, and they looked to see what was protective in the relationship between sun exposure and melanoma risk. And what they found was very interesting. They said, quote, overall, the clearest relationship between reported sun exposure and risk was for average weekend sun exposure in warmer months, which was protective. In other words, if you had weekend, that reduced your risk of melanoma in these subjects. They say serum vitamin D levels were strongly associated with an increased weekend and holiday exposure. There's no surprise there. The more you're out in the sun, the more vitamin D making from the ultraviolet B radiation. What about the risk factors for dying from melanoma? This was a study that was published back in 2005, and they looked at what things were associated with increased death in melanoma and what things were associated with a decreased death rate in melanoma. And you can see that things that were associated with an increased death risk was melanoma thickness, mitosis, ulceration, and head and neck placement. So mitosis is when you see the cell under the microscope. Things that were associated with decreased death was actually things that are associated with being in the sun. So sunburn was actually associated with a decreased death. High intermittent sun exposure was decreased. Something called solar elastosis, that's kind of the damage that you have to your skin if you're out in the sun for too long, was actually associated with a decreased death rate. I'm not saying that going out into the sun you're going to be fine and never get melanoma. I want you to listen to your dermatologist. But remember that near-infrared radiation, the thing that stimulates melatonin production in the mitochondria, can penetrate through clothes. And so you don't need to go out into the sun directly. You don't need to be going out and sunbathing without protection. It can penetrate through clothes. It can penetrate through sunscreen. But just to say, you don't have to be afraid of going outside even when the sun is out. You can do this, and remember that the green leaves reflect a lot of that near-infrared radiation. Here's a study that was done titled Avoidance of Sun Exposure is a Risk Factor for All-Cause Mortality. Results from the Melanoma in Southern Sweden cohort study, about 30,000 women selected at random, 35 to 64 years of age, in Southern Sweden, and followed prospectively for 20 years. And there was about 2,500 for those 20 years. And they asked about, did they go to the tanning salon or were they sunbathing? And this is what they showed. Showed that those that had avoided sun exposure, they had sun avoiding behavior, their survival rate was this line here at the bottom. whereas those that had the most active sun exposure were those here at the top. So this is a large study and a very large and long follow-up. Most Swedes, of course, are fair-skinned, and so this can be something that's applicable to a population that's at risk for melanoma.
That was really interesting to see that graph with UVA and UVB and the amount of oxidative stress that those portions of the light spectrum cause relative to infrared. And most sunscreens that people buy these days are broad spectrum sunscreens, meaning they help block out both UVA and UVB. But I also want to ask about, you mentioned melanoma, but there's other skin cancers out there. There's basal cell carcinomas and there's squamous cell carcinomas. They're not as deadly as melanoma typically, but what are your thoughts on, people that are concerned about all types of skin cancer and want to stay out of the sun, also because they don't want wrinkles. A lot of people want to avoid the sun for those reasons. So what's a strategy they use to still get infrared radiation?
So I too am also very conscious of sun exposure. I mean, I'm tinting a little bit here on the top, so I wear a hat, so it protects me from the ultraviolet radiation from the sun, and obviously wearing clothes, shirts, things of that nature can do the same. But the key here is that infrared radiation can penetrate through those layers of clothing. So I can still feel the warmth of the sun on my head, even though I'm wearing a cap. And so, yeah, basal cell carcinoma, squamous cell carcinoma, even sun damage, actinic keratoses, these things are related to the oxidative stress that is occurring from that particular portion of the spectrum of light, which is in the ultraviolet spectrum. And that can be by making sure you're wearing sunscreen, that you're covering up, but you can still go up into the outside and get that infrared radiation because it will penetrate those protective barriers.
And if you don't have a way to cover your skin or you forgot your sunscreen, can be in the shade and benefit from near infrared?
Well, absolutely. So remember that the sun is shining down leaves, these plants, the grass, which are highly reflective of near infrared radiation. So even though you're not in the sun, you could be in the shade, getting the benefits of that near infrared radiation that's hitting you, even though you're not in direct sunlight.
אבא שלי בפעם הראשונה שנולדתי, הוא החליט לעזוב אותי. רציתי ליצור איתו קשר, להגיד לו שינסה לחזק אותי. גם אז הוא לא ענה לי. כל השנים אני ואמא שלי נלחם בעד.
Here's a paper that was done at the interdependence and contrast exposure and vitamin D to MRI measures in multiple sclerosis. Now, I found this very interesting because scientists have known for a long time that multiple sclerosis has a higher incidence at higher latitudes. So, in conclusion, the results from our cross-sectional study suggest that sun exposure could have an effect on brain volume in multiple sclerosis. Now, remember we talked about how infrared radiation can penetrate the skull and actually can bathe the cerebral spinal fluid in near-infrared radiation and be trapped down deep into those sulci where the gray matter is. What they found here was that increased sun exposure seemed to improve the amount of gray matter and gray mass, and it was dissociated from the increased vitamin D levels as a result from that sun exposure. Let's take a look at this graph here. I found it very interesting. Here we have the multiple sclerosis patients up on top, and here we have the controls on the bottom. And what they did was they divided sun exposure into quartiles. So they had the people with the highest 25% of sun exposure, the third highest, the second highest, and then the lowest in all of these categories. And what they measured here in the first graph was the gray matter volume. In other words, how much gray matter was there on the MRI. And you can see a very definitive positive association in multiple sclerosis patients. The other thing that they looked at over here on the right side was the whole brain volume. So did the whole brain volume go up? And you can see clearly that there was also an increase in whole brain volume with increased sun exposure. In the controls, it was not as dramatic, but you can still see that there was a positive correlation. Whole brain matter, not so much, maybe a slight amount. But remember, this is gray matter here on the left, and it's the gray matter that's on the outside of the brain and is easily accessible to potential near-infrared radiation.
Still in this pandemic, dealing with COVID-19, can any of these health benefits that you described from infrared radiation benefit us with regard to COVID-19?
So MedCram viewers will know that back in May of 2020, we talked about oxidative stress associated with COVID-19 infection. And we said at the time that angiotensin 2, or AT2, which is pro-oxidant, is converted to angiotensin 1,7, which is an antioxidant, by the ACE2 enzyme, which is also a receptor. And that's the issue. Because ACE is not just a receptor for the spike protein, an enzyme which is keeping the oxidative stress low in the cell. As we said, angiotensin 2 is a pro-oxidant, and so it's going to lead to a lot of species. However, AT17 is an antioxidant. It's going to suppress reactive oxygen species, which is good. That's what we want to do. The problem is that when the virus infects, binds to that ACE2 receptor, it knocks out that enzyme. And so instead of angiotensin 2 going down and angiotensin 1, we have the opposite occur. And so what we have is angiotensin 2 going, angiotensin 1,7 going down. And not only that, but the virus itself attracts white blood cells, which also has oxidative stress, as we talked about earlier. Things lead to an increased amount of reactive oxygen species. So if you think about this, going back to the analogy of the engine, imagine that your antioxidants, your cooling system is not working very well. And so as you're driving, it's running a little hot, which is not good. And then all of a sudden, what happens is you hit this hill, which is called COVID-19. And as you're going up the hill, that's enough to cause your engine to fall over just the edge, where now it's overheating, steam is coming out of the engine, and you're pulling over to the side of the road. That's the issue with COVID-19. It's taking patients who have high oxidative stress levels already because they're not optimized, and it's causing them to go over the edge. So we've talked about this. This is why patients are coming into the hospital, because this reactive oxygen species are damaging the endothelial cells, which line the blood vessels. That causes microclots to occur. That leads to hypoxemia and increased oxygen levels. The solution is having melatonin to cool down that engine. Melatonin that comes intravenously from the pineal gland and goes into the cells to reduce the oxidative stress. Melatonin, which is coming from the sun through near-infrared radiation. If you're getting these things, you're actually benefiting and you're less likely to run into the consequences of COVID-19. Here's a paper, Kyle, that was published last month. 60 patients admitted to the hospital, and they measured the levels of glutathione, which is an antioxidant in the cell. They looked at TBARS, which is basically a measure of oxidative stress. And they also looked at something called F2 isoprostane, which is a marker of oxidative damage. And this is really interesting. I want to make sure that people understand this. So here we're looking at intracellular reduced glutathione. So this is an antioxidant. First of all, I want you to notice that in the control subjects, which are in blue, that as we get older, here's the 21 to 40, the 41 to 60, and the 60-year plus, notice that these levels are going down. So that's important to understand, that as you get older, your antioxidant system gets worse. Kind of like a car, right? As the car gets older, it's more likely to overheat. But notice that in the COVID patients, there was a significant drop, especially in the younger. There was a significant drop in the measure of intracellular antioxidants. Now remember, what is it that regulates glutathione? We already said it. It's melatonin. Melatonin is the product that increases glutathione inside the cell. So when we looked at oxidative stress, and that's plasma, TBARS, notice the same thing. As we go older in the control groups, the amount of oxidative stress went up, but even more so with those in the COVID group. So again, increased oxidative stress with COVID-19 infection. Finally, when we look at the measurements of damage with F2 isoprostane, we're seeing here consistently across the board regardless of the age group, that COVID patients had higher levels of oxidative damage.
Ну,
It's
видишь,
very
у меня ненормальный запрос на какой-то, или там нездоровый. То есть работу мне не дают, я себе работу выбрал, мне работу не дают. Может, я сам себе не даю работать, не знаю.
clear. If you look at the data, this is not
Ну, ничего
controversial
страшного,
in
что
any
будешь
way,
делать?
shape, or form. That your vitamin D levels, if you look at the data, this is not controversial in any way, shape, or form. That we have seen over and over again that people with high vitamin D levels, as you can see here in this study of 185 patients, people with high vitamin D levels or higher vitamin D levels had better survival probability in COVID-19. And those with low vitamin D levels had lower survival. We thought that maybe because vitamin D levels were higher in those people that survived, that by giving vitamin D, we could actually improve their outcomes. And for sure, in some studies, there has been a modest improvement in survival when we gave vitamin D to patients who were in the hospital or even before. And there's many studies that show that chronic vitamin D supplementation can help reduce some of these acute chest infections. But what I'm believing more and more now, Kyle, is that vitamin D, yes, can be used, but it's also a marker of sunlight exposure and therefore infrared radiation. And so it's possible that by seeing high vitamin D levels, we're seeing the effects of infrared radiation at the mitochondrial level and the antioxidant level. I'm beginning to understand that it may be a mistake to think, in other words, that if you have your vitamin D supplementation, that you don't need to go outside and get infrared radiation. I think that would be a mistake if we thought that. And one of the reasons why I believe that more and more now is because of this study, which was published in the British Journal of Dermatology, and it was conducted by researchers at the University of Edinburgh. And what they basically did was they looked at the United States and they cut out the portion of the United States during last winter, in the winter of 2020, where there would be enough vitamin D production if you went out into the sun. So they cut that portion out. They only looked at the portion of the United States where there wasn't enough sunlight to make any significant vitamin D. And even in that portion, so this portion up here, they were able to show that increasing levels of sunlight led to decreasing COVID-19 mortality. When they figured that out, they went ahead and prospectively applied it to the country of England and also to the country of Italy. And they found very similar results, that as sunshine levels went up further in the south, they found that mortality levels went down. Same thing here in Italy. So what they decided was that something was in the sunlight other than vitamin D that was causing a decrease in mortality. In conclusion, this study is observational, and therefore any causal interpretation needs to be taken with caution. Granted, there's other factors that could have played into this. However, they say, if the relationship identified proves to be causal, it suggests that optimizing sun exposure may be a possible public health intervention, given that the effect appears to be completely independent of a